Nesting blocks. A program is made up of a sequence of statements, known as a body. We sometimes refer to bodies as a block or chunk of code. With if statements and function definitions, we have ways of putting a smaller body inside of the main global body. But now we will see that we can also put if statements inside of if statements and functions. We call this nesting the bodies inside of each other. As you develop more complex programs, you will do a lot of nesting. Every time you nest a block of statements inside another block, the body of the block gets indented another 4 spaces. Observe the Python code on the right and the numbers on the left. Each level of nesting increases the number of space characters by 4. These are called the whitespace rules, and they can be confusing, but they are consistent. The amount of whitespace controls what code is in what body. You can put if statements inside of functions. In fact, this is both common and useful. Remember the whitespace rules when this occurs. Each nested block is another 4 spaces in. In this function adjustPrice, the first line of the body is indented 4 spaces, but the second line of the body is indented 8 spaces. The first line after the body of the function is not indented. In fact, that's what makes it the first line after the body is because it's not indented. It can be difficult to know if a line of code belongs inside or outside of a block. You must think critically what you are trying to do with the if block. Remember, statements inside the if block are executed only if its conditional evaluates to true. In the code shown here, the first assignment of the price variable is after the if statement's body, while the second assignment is inside of the if statement. That means the first assignment will always be executed, but the second assignment may or may not be executed depending on the value of cost. In addition to the if and else blocks, there is a third type, elif. The elif is exactly equivalent to an else block with an if statement inside. Although they do not offer any new power, they are sometimes more convenient to write. The following 2 pieces of code may look similar, but they are quite different. The code on the left has 2 if statements, and both will always be evaluated and potentially executed. The code on the right has an elif statement, and the second will only be evaluated if the first one evaluates to false. 2 kinds of mistakes are very common with if statements. The first common mistake is using an if statement when a conditional expression is fine on its own. For example, consider this function definition that returns true if the parameter is greater than 5, or otherwise returns false. The conditional expression already evaluates to either true or false, so it wasn't necessary to use an if statement. Instead, you can directly return the result of the conditional expression, as shown on the right. You do not need to use if statements if you are just returning true and false. A second common mistake is to test if a Boolean expression is equal to true. While the expression here, age greater than equal to 5 equals true, reads like it makes sense in English, it is redundant in Python. Age greater than equal to 5 already evaluates to either true or false. If you compare a Boolean value to true, then the result is the same Boolean value. Nothing is accomplished. You have simply made your code more complex. It's just like adding 0 or multiplying by 1 or adding the empty string to a string. Literally nothing will happen. True would become true and false would become false.